if you listen something about the earthquake, you might start worry about the earthquake. But if you are listening other type of disaster, your whole way of thinking is going that direction. And then the difficulty is how can we make a comprehensive discussion of the different type of the issues. And that is the main issue that we would like to raise here, because individual technology and individual proprietary modern technology, we have many. However, have you ever heard that the disaster was reduced recently? Probably not, because the disaster is increasing every year. It seems to be, and the people suffering the disaster, in the one side, it's decreasing. However, in the other side, it's increasing. So which means that preparation of the disaster, like a structural measure, can prevent the people killed by the vibration. However, the preparedness for the occurrence possibility, that might disturb the how many times it's happened. So can you show this? Yeah. So I'd like to, mainly we like to discuss according to this table, and if it's right and if it's wrong, and discussing the wide variety of the different types of disaster. But first of all, I would like to ask the Professor Isobe. So I mentioned here the superflare description. It's attacked only the modern civilization. It's a 10 to the third power, the occurrence. It's every 1,000 years, the big one. But the last one we know is the Carrington. But you say that it was happened in the 1,000 years ago, right? And and can you comment and can you modify according to your knowledge? And
well, the Carrington event, which is still very disastrous for the modern civilization, occurs probably once in 100 or 200 years. I'm saying this because as I briefly mentioned in my talk, we have found some aurora observation, which is, at least in terms of the latitudinal extent of the aurora, that is comparable or even stronger than Carrington. I think we haven't got a Carrington class event since 19th century, but I think in average we have something like once in 100 to 200 years this sort of event. And when it comes to the once in 1,000 years event, at least we have some indication of the carbon-14 content in tree rings as well as associated aurora that maybe around 10 times stronger than Carrington event occurs in 1,000 years. But for that, we haven't got that much strong evidence. So I think we still need to work on to look for the historical event and also the cosmogenic isotope studies.
Yeah, the important message I like to extract from the Professor Isobe is how we should worry and for what kind of the superflare and how it is happening. It is frequent. Are you saying that everybody has to prepare for the big superflare event, or you think that is the low probability but high risk event? And there are both sides. Of course, you have a small flare but big flare. But what you would like to send the message for the audience for the?
First of all, people who are operating satellite already very much aware of the risk of the extreme space weather, but the point is that so at least we have to keep monitoring the sun. However, so far the solar observation is essentially funded by funding for academic research, not for operational purpose. Only some U.S. military have some funding to monitor that sort of things. And actually, we rely on the solar observation mostly from space now. Space is good because there's no cloud, there's no nights. You can continue to watching the sun 24 hours. However, space assets are very much vulnerable to the solar storm itself. So once it happens, I mean, the huge flares can destroy all the space assets. Then and if we don't have any other way to monitor the sun, I mean, we cannot know even what's going on the sun. So from that point of view, the ground-based facility to observe the sun is also very important. And our student, Seki-san and the Dennis-san from the Graduate School of Science, I think tomorrow in poster session, there will be a poster by these students who are discussing the importance of the ground-based facilities to monitor the sun.
Yeah, I think the ground-based facility in the Kyoto University, there are long-term the observation system has been established too, right?
Yeah. But from the warning point of view, actually, we wish to learn from the scientists of the earthquake and tsunami because, recently there was a case in Italy that scientists are brought into the court because they made some wrong prediction. And we astrophysicists say, okay, this is dangerous, that's not dangerous, but we have, okay, I dare to say that we have not been that serious as we think about the possibility of brought into the court.
Yeah. Okay, so if you say so that we have to address Professor Jim Mori about the risk of the earthquake, that you mentioned that probably not going to happening, we don't have to prepare for the magnitude 9 earthquake again in our lifetime, but everybody is worrying about the Nankai earthquake and probably in the Kanto earthquake in Japan. But in the different countries, there are many. It's different. And can you say about that? I put just 10 to first power in the occurrence of the frequency, but
right.
and also the Italian case, this is also
okay, well, that's a little bit different.
It's a serious. Thank you.
I said probably we won't experience a magnitude 9 in Japan, but one thing good about earthquakes or seismology is a global study. So over your lifetime, you probably will see a magnitude 9 in some other place in the world. Indonesia or Alaska or South America. So that's one good opportunity or one good way to try to keep people not interested, but keep people tuned to the fact of these very large earthquakes. So they are happening all over the world. I mean, it's like in astronomy, you use space as a proxy for time. Same thing in seismology, we see earthquakes happening all over the world. So large earthquakes do happen, large tsunamis do happen, and I think it's important to have an international community that can focus on those different problems, and then you can bring that information back home and apply it to your own region.
The scary thing of the earthquake that we don't know when it happened, because I think almost 1 month ago that there is a Tottori earthquake, and no one has expected that Tottori is vulnerable for the earthquake. And then there is a literature review that happens a long time ago, and that is a region. And then every time when you have an earthquake, there is almost no warning and no prediction, but it happens, right? So can you comment on that?
So right now we cannot predict earthquakes. We would like to, but there's no sort of magic precursor or sign that we can use to say an earthquake is coming.
Even the best scientists of the earthquake can think about that.
Excuse me. The best we can do is this early warning, which can give you a few seconds of warning before some strong shaking happens. But yeah, right now we can't do a short-term prediction. We can do relatively good long-term forecasts. And long-term means 20 to 30 years. And those have been fairly good over the last 5 or 10 years. But since we can't do the prediction, and I always tell people, don't expect to get a prediction. But it's one of those things where you should really be prepared that if it happens 5 minutes from now, you know what to do, how to react. And that's all part of the education and preparedness plans that Japan is doing right now.
Yeah, there are a lot to discuss about the earthquake, but coming back to this table, and then one by one, I would like to review. The GLB is, the GLB is a gamma ray, but probably it's going to be happening because it's a frequency is a 10 to the 9th power, or it's a billion years, every billion years, probably in our lifetime, in the future generation. It might be safe. However, the supervolcano might happening, and Aso is exploded this year, and it's very small scale, of course, but and then everybody is worried about the Yellowstone next explosion, but this is just rumor or this happening. And then we like to focusing on the asteroid attack that I am very personally worried about, because it's a real extinction level event that happened 65 million years ago. And it's locally, it is happening almost every every year or every day, right? Small meteorite. And there is a specialist today joining us, who is Dr. Yoshikawa from JAXA, and in the audience. So I'd like to invite a little bit about his observation about the occurrence of the asteroid by introducing this figure.
Okay, thank you very much for introducing me. I'm Makoto Yoshikawa from JAXA, and currently my main work is asteroid mission, Hayabusa 2. But my another work is this one, asteroid collision to the Earth. So I quickly explain this figure, and this shows the distribution of near-Earth asteroids. This means that these asteroids have possibility to collide to the Earth. And this shows the center part is the Sun, and the orbit is Mercury, Venus, Earth, Mars, and this is Jupiter. And this gray dot is all the asteroids that we have found now. The number is about 720,000 asteroids, now we know. And this blue dot is the near-Earth asteroid. The number is more than 15,000, and this number is increasing. Can you change next one? So this is the inner part. So you can see this is the orbit of the Earth. So in this region, there are lots of near-Earth asteroids that have possibility to collide to the Earth. And actually, this number is increasing year by year. So please show us next. Yes, this figure shows the number of near-Earth asteroids found up to these years. So now we found about 15,000 near-Earth asteroids, but the number is increasing and increasing. This color difference is the size difference. This M is the absolute magnitude of asteroid, and this means this red part is the size is more than 1,500 meters. So this is a big one. For the big one, the increase is not so rapid. But this part, the green part, is the size is less than 150 meters. Such small one is increasing and increasing. So we must find such asteroids which are not discovered yet.
Can you just think if the smaller one
Yes.
hit to the Earth,
Yes.
what may happen to our city, and how is it big? Is it equivalent to the Hiroshima bomb, or the smaller than that?
Yes, actually much larger than Hiroshima bomb.
Even in the small one?
Yes, right.
Even in the small
Yes.
one, okay.
For example, as Professor you explained in your speech, a few years ago there was a meteorite in Russia, Chelyabinsk. In that case, the size is just 20 meters or so, but there was a very large destroyment. So it is very...
So that is the city-killing asteroid is happening
Yes,
more
right.
than, and it is increasing every year
Yes,
because of
yes.
the capacity increase, our,
Yes.
our observation. We have to think about that.
Right.
This is terrible. I didn't know that, but I knew that, but I didn't know how serious like this situation, because he's a professional. He's the best person. He made a calculation for the Hayabusa mission, right?
Yes, right.
Hayabusa mission. Yes. So he's the authority. So authority is saying the same. I'm scaring. But thank you very much for
Thank you very much.
Okay.
May I ask some question?
Oh yeah, please.
May I ask, do you have some theoretical estimate of where is the saturation level of this?
Yes. For the smaller one, NASA says only 1% now we already found. So still 99%. I mean, just 10 or 20 meters in size.
What is the physical background of NASA saying that?
We have a size distribution model from,
Okay.
yes, we derive this from the observation data.
And what are the things we can do except for monitoring them? What are the things we can do to prepare except for just monitoring them?
We have to establish a network, and then
Yes.
we have to observe, right?
Yes, anyway, at first we must discover it.
Yeah.
And then we calculate the orbit. Then we predict where and when it will hit the Earth.
Thank you very much. So probably we have many things. Before there is a superfluous that has been discussed, and global warming and the outbreak of the infectious disease. That I would like to discuss tomorrow mainly because after the Mitsuyama sensei's discussion, the terrorism and earthquake and tsunami and flood and singularity. Actually, singularity. We not today. I don't know at all about this about the profession. But before there are, I would like to invite a comment from Professor Arimoto, who is the professor of the
National Graduate
Please.
Institute for Policy Studies, Tokyo. Sorry, I have to leave here for Tokyo just right now. Just my question and comment, Professor Mori. Your conclusion is very important. The second point is the technology of the warning systems worked very well at the time. But the better response information and education is needed. But everybody should recognize the exceptional example is you may know at the time, even at the emergency time, Japan Railway companies successfully stopped the bullet train. At that time, the bullet train running 16 or 17 train systems running at high speed around 300 kilometers per hour. And the Japan Railway installed the early warning and the detection systems coastline around the disaster areas. So detecting after detecting the P wave. So the P wave, detecting directed running bullet train within the 1.5 minutes successfully. Even without the delay of that train. But many after the big wave, S wave impacted that railway systems, destroyed some portion. So that is independently the Japan Railway companies installed, different from the meteorological agencies, the conventional systems. That is very important lesson learned for future about discussion.
Professor Mori, can you comment on
Yeah, I'm glad you mentioned that. That's very good. And actually, that's sort of the point I was trying to make is all the systems that don't have human intervention worked very, very well. And it was the problems with the information where people have to do something or react to it that we need more work on. But yeah, certainly the early warning system, the Japan Railway one, the JMA one, and all of those sort of technological systems work very well and probably saved quite a few lives.
Okay, so there is already, I was thinking to ask you, both of you, about the commenting, especially in this table, and also if you make a question before, can you summarize or can you give an opinion about how you handle these kind of different topic, different disaster into one single dimension? You say the 3 dimension is enough, but if you, any kind of comment is welcome from you, right? From
Okay,
Cambridge.
I think your question I will leave to Shahar to comment on in a second. Let me just follow up briefly, Professor Mori. This was very interesting to me. I've been working on the tsunami risk in Japan for a while, and I have one question, which is a question from a lawyer to a seismologist. So please accept my apologies. So you've pointed out very rightly, I think, that Japan has done a very good job with regard to its construction laws in terms of the Taishin Kijun. But construction law is not only about Taishin Kijun, it's also about zoning, right? Zoning is also part of construction law, and we will probably have to admit that with regard to zoning, there was a terrible job done in Tohoku, because there are a lot of people in places where they probably shouldn't have lived. So that's my first question. What about zoning laws? And the second question is complete open question. Do you know, because you've mentioned about the time horizons of 500 years and how that's not even enough with regard to earthquake prediction. Now, with regard to tsunami prediction, what is the current time horizon for the height of the tsunami with regard to the tsunami walls that are in place to protect nuclear power stations? What's the time horizon for that? And has that been changed? And should it be changed?
Okay, the second question's easier. Excuse me. So basically, magnitude 8s happen every 100 years or 50 years. And so those 10-meter type walls will probably be okay for the magnitude 8s. But because this was a magnitude 9, it was so much bigger. And like I said, those repeat times of the 9s are probably about 1,000 years. And so, but then on the other hand, you aren't going to build a 30-meter wall around your coastline. So you need a different kind of solution to address that. And they're talking about things like what they call vertical evacuation, identifying high places or hills with ladders or steps or things like that that people can go up. Yeah. So okay. So a magnitude 8 happens maybe every, I don't know, 30, 40, 50 years in the Tohoku area, and will produce tsunamis sizable, maybe up to about 10 meters, something like that. But the magnitude 9, the 1,000-year event, is the one that has these really 20 to 30 meter heights. And of course, these are all probabilities. It could happen tomorrow, but that's sort of the reasonable kind of answer. The other question was about zoning. And actually, I don't know very much about that, but I gather it's a very difficult problem because people want to live where they want to live. And you know, if you have a coastline place for your shop or your home, it's very difficult to tell someone you can't build there, especially for something that's probably not going to happen in your lifetime again. And so that's a real issue. And they're talking about things like reserving certain areas for parks or other kinds of areas like that. But there's no easy solution to that because people want to live where the view is good.
Okay, so
Okay, so I guess I'll start with the comment, which is, you know, we have a classification system that tries to put all of these things together, but unlike the natural risks that, you know, we're seeing more and more the establishment of these very reliable power laws that are a very powerful tool that can then be taken up both in education and in reinsurance. For the more anthropogenic risks, these kind of power laws are very hard to establish. It's not clear that this is going to be how they play out. And also some of these cascading scenarios where something starts with a natural disaster but then plays out in the human domain, we need to go towards a much more holistic, interdisciplinary scenario planning in order to understand how they might play out and prepare for them. So I guess this would be our take on some of this. But if I could follow up with some question. One question which is very serious for both of you, which is the question of global spread. Right? So if we want, if we're worried about some kind of catastrophe affecting everyone on the planet or a majority of the population of the planet, do you see any scenario in which case an earthquake could lead to something like that? Because I think causally there isn't going to be a global earthquake, but maybe, earthquakes hitting some kind of critical infrastructure and in that way having a global effect. So is it something that has been considered? And similarly for space weather, here we might see more clearly how an effect could have, how you could have a global effect, but whether some of these scenarios have been looked at in more detail. And perhaps more speculatively, right? Elon Musk and others are talking about making humans an interplanetary civilization as a way of addressing some of these risks, right? Because the cascades are limited to one planet. Space weather seems to be one way in which this will not help us. So the effects of space weather on maybe some concrete plans of colonizing Mars, or sort of more speculatively into the future. If you could comment on that.
Well, for the last one, for interplanetary colonization, yes, definitely the radiation from the sun is, I think, the most difficult factor it's most serious factor to realize real interplanetary travel, because if you travel from Earth to the Mars, you have to spend 6 months to a year in interplanetary space, and within that time you'll be exposed about 2, 3, 4,000 sieverts in total. That is very, very large, and no one has experienced such a large amount of radiation in such a long time. So you definitely need to something to prevent such radiation load to realize interplanetary travel. But essentially, all you can do is to have a huge, thick wall, which is very, very expensive. And also, at the Mars surface, because of the very tenuous atmosphere of the Mars surface is actually lots of radiation comes from space. So even on the ground of the Mars, you are exposed to the lot of radiation. So that's really an issue, which is very, very difficult to prevent. And about the global effect of space weather, one thing which is certain is that even in a Carrington-class event, essentially all the space assets will be destroyed. So probably it doesn't hurt the health of human beings on the ground, but suddenly all the function provided by the satellite, like weather forecast and the GPS navigation and communication are lost. So there must be lots of confusion in transportation and communication. And there are a few studies about the possible effect on this failure of the communication and the satellite navigation on its consequence on the global supply chain, for example. But I think no one has really studied the complete destruction of space asset. So from that point of view, I think we need to do some more study.
We didn't prepare for that. It is Sotegai.
Yeah. So actually, one thing I want to question to both Mori sensei and both of you is that actually education is one important thing. Education or public awareness, because as I say, people want to live in a place where they want to live, but in order to avoid risk, people have to live in a different place. So we have to convince them to react to the potential risk. But maybe for those risks which happens once in several years, they can predict. But if you are taught to prepare for the risk which occurs once in 1,000 years, probably you don't do anything. But I don't know if you have done any study or trial in terms of the public awareness of these existing risks, or is there any good way to?
Yeah, this is a very important point that we like to discuss. And in this table, in the above, it's a very huge extinction level event that's rarely happening, like the occurrence is 10 to 8th or 10 to 3rd or 10 to 5th. And this is more daily or more common disaster, is I am putting, except the singularity. Because singularity, once it's happened, it's over, it's said. But so if you classify these two, especially for those person who is responsible for putting the money, so how can you allocate the limited resources, and also how can you withhold the information, the consequences that might happen if these things happen as you prepared or you imagined, right? So, for example, he's saying that if the Carrington class flare happened or bigger one happened, maybe it's a big disruption in the all electric circuit, and probably it's a world catastrophe may happen. But if you say so, can public accept that the warning, right? The one side, if you overdo or exaggerate that risk, then the public may be aware or fear for that. But on the other side, in the case of the Italy, in the seismologist, he didn't warn. So because of that, he was jailed, right? He was responsible for that didn't alert. So there is a two distinct responsibility for the scientists. And if you can very shortly comment about this too.
Okay. First, just to answer your question about a global seismic event, the physical dimension of earthquake is probably about 1,000 kilometers, so that's not going to happen. But what has been talked about is the financial effects. If Tokyo gets flattened, if Los Angeles gets flattened, that certainly would be a world, affect the whole world. And also, one thing we didn't talk about much is volcanoes. Like Pinatubo volcano in 1991 reduced the temperatures by about 0.3 or 0.4 degrees. So a very large volcano will definitely cause large famines, which has happened in the past. The Italy case, I don't know if people are familiar, but there were actually some seismologists and government committee members that were found guilty of negligence because they didn't give proper warning before an earthquake happened in L'Aquila in Italy. And as I said before, we can't predict earthquakes. Seismologists can't predict earthquakes. So the scientific committee was just sort of outraged that scientists were being held responsible for damage that happened. Okay, it's a complicated story, but what the government was saying is that the seismologists were responsible because they were saying things like because they did not give a warning about the earthquake, which is different from saying that there won't be an earthquake. But so the information they're giving out was tending to try to calm people down and say there wasn't going to be a big earthquake, although they didn't say it that carefully. But that just raises this issue about how responsible are scientists for these consequences, and how responsible are we to give information out that we know of. So it's a really excuse me, difficult problem. But that's sort of the importance of having committees, of having government-authorized committees where these things are discussed in private, and then policies are given to the public in terms of what seems reasonable. And in Italy, that didn't work very well. The policy that the committee gave out was considered to be not very good. They didn't have proper notes, and so there was a little bit of negligence that was going on. But I think in general, in Japan and the US, any kind of scientific evaluation committee has very formal procedures.
Okay.
And so they won't be held for, they word things very well for those kind of cases.
Thank you very much. And I think it's good to ask for the audience about the discussion. I like to invite some of the questions addressing the probability and also the classification between the low probability, high risk event and also the daily disaster. And if your audience have some individual comment, or if you have some questions about the speaker, Professor Mitsuyama. And if you can address also the outbreak of the disease, I didn't talk anything about that. And in addition to that, because he will give a plenary talk tomorrow too. Yeah.
Outbreak infectious disease will be discussed tomorrow, but thank you for the talks, and I understood there are a lot of the variety of the disasters, but what I don't understand is that sometimes the one particular type of the disaster is emphasized or overemphasized by the frequency. Well, it may happen so quite soon, or some scientists emphasize the the different type of disasters, even if it may not happen in the coming 100, 200 years, but if it take place, it causes the global disasters or catastrophe. So my question is there some standard parameters or the measures for the ranking of the disasters based on the frequency and the possible negative effect or the loss of the
that
human.
we are looking for, and that
Yeah.
we would like to establish together with the University of Cambridge, if possible. Like the frequency analysis is important, and also the impact analysis is important, and also not only the structure, you have to understand the mechanism, and also the possibility for the avoiding.
And also,
yeah.
according to the type of the disasters, the people, like as an ordinary people, like us as a student, may have the different impressions. For instance, asteroid collision. We believe that asteroid collision may result in a very terrible disasters. But we, at least I, will think like this. If it happens, and if I am involved in that, I will die. I will give up and I will die, along with all the other people on the earth.
Yeah, but if you watch the Kimi no Nao movie and there are asteroid attack happening, it's a joke. Like,
So there is some other factors in addition to the frequency and the damage, which can be measured by the. But
yeah, what you're saying is essential to our discussion because we want to normalize, but we are trying to normalize that. We set up a frequency, but the public people, probably you are more familiar with those risks, earthquake, tsunami, and flood, and probably the debris flow. And and also probably you are worried more about the financial risk or some kind of the different, and probably the terrorism. Terrorism is a real threat for our journey, right? And so these high frequency disaster, it's becoming more familiar. And we are many times forgetting about the low probability risk. Is it right? So that is our understanding. Also, some disasters are overemphasizing. I don't know if it's because of the budget request or public understanding, but the biggest one is the Tokai earthquake, and it says it's almost 30 years ago, and it's still not happened. But I don't say it will never happen. It will happen, but we don't know when it happened, right? And that is difficult for us, but if you have some same impression or if you have different opinion, can you raise your hand and please, Professor Ohashi? Yeah.
I think the value of information is determined by what you can do using that information. So I'm sorry using this example, but for if you can predict very accurately when the happening of earthquake, but 1 minute before, then that information has very little value because what you can do is just you go into the table or something. On the other hand, we know that in some area, it's likely for us to have some big earthquake. At some time, we cannot say. And in that case, we can utilize that information, for example, to build to make the building very resilient to the big earthquake, or say we don't live in that area or that one. So what I'm suggesting is that maybe we can see those a bunch of that events and classify them according to the information that we can create, and also the way that we can utilize that information. And in that way, we can maybe give them a priority. That's what I think.
Yeah, that is a philosophy for the hazard map and also for the preparedness. And probably that is, I think, it's undergoing, right? Not only the seismic and earthquake disease and tsunami disease and flood disease. And there is another contradicting opinion that we have published so many hazard maps, right? And the people are very familiar with that, and no one cares the hazard map, except there is already risk written there. And so if the people is so much familiar with that, please, if you can mention about this. So, Professor.
Yes, I think there would be one very radical measure to make people feel this hazard map. And that measure would be to liberalize the premiums for earthquake insurance in Japan. Because right now the premiums are set on prefectural level by the insurance companies in coordination with the regulator. But basically your earthquake insurance premium depends on which prefecture you live in. It doesn't matter where you live right by the shore or you live on the top of a volcano. It just depends on what kind of house you have and in which prefecture you live. So as long as you don't deregulate that, you have no signaling function of your premiums and of your hazard maps. The moment you deregulate, people who buy a property, they will see how much the insurance costs, and that will be a strong signal for risk. And then you will see that people will suddenly not want to live by the sea or on the top of a volcano because it's too expensive. And you kind of re-internalize the costs that are now put on the taxpayers, because the taxpayers are eventually have to pay for all the supplementary budgets that have to be put in place to compensate people who kind of banked on disaster risks by living in dangerous areas. So I think once you deregulate your earthquake insurance premiums, you will see something happening. That's a provocation.
Thank you, Julius. Thank you. Shaha, please. Are you talking? No, you're mentioning.
Yeah, and to generalize from that point, I think. So the limit with this kind of list, and also a limit with the classification framework that we presented, is that you need to get at the impact on individual life, not just as a communication mechanism, but genuinely this is what we're here to do. We're here to help people live a safer life. And so, I mean, I'm pushing on this global effect precisely because we need those scenarios, right? I don't just say, what does the power law look like and what is the evidential basis for it, but given a relatively well-established power law, what is the cascade? You know, should we have an interdisciplinary workshop with the people who manufacture the transformers for power stations, where we bring the science with the industry, where that is the most effective intervention? If the most effective intervention is communicating disaster preparedness, then we need to bring in the expertise on risk communication that we have in Cambridge Center that is now spinning up precisely on how you do those kind of things. So I think we need to break out of the silos precisely so that our information could be relevant. And also I think we'll get better science out of it because we can have sharper questions.
Thank you. I'd like to invite one question to Professor Koyama because he will be speaking tomorrow, but from the point of the history of the disaster, because this table are missing the like 1,000-year scale or century scale, the past disaster, or the after the human presence of the human and also the historical disaster. And if the Professor Koyama can comment on to the what is missing, well, in the point of view of the from your specialty.
A lot of I would like to ask one question to Isobe sensei. I'm a historian, and I agree with you that historical documents tell us how people reacted to extraordinary natural events in the past. And tomorrow, I will show you some examples of such various reactions from the 17th century Polish documents. And my question is about the correlation between the solar activity and the climate on the Earth. You pointed out that the solar activity was not a disaster in the past. Your comment is very interesting because it suggests that the common parameter concerning disasters must be changed according to historical condition, the level of technology or kind of political or social structures. But I understand that your comment means that the sudden and extreme increase of solar activity like super flare was not a disaster in the past. But I want to ask you, what do you think about the lower level of solar activity? Because the 17th century is known as the period of a relatively low level of solar activity, the so-called Maunder minimum. And on the other side, this century is known the period of lower temperature, the Little Ice Age. And some scholars, including famous British historian Geoffrey Parker, suggest that there is a correlation between the lower level of the solar activity and the lower temperature on the Earth.
Okay.
Is it correct?
Professor,
or can we add this lower activity of lower level of this solar activity to this table?
Yes, first of all, I emphasize that the solar activity was not a disaster in the past because in order to emphasize that there is an increasing vulnerability from the space weather. But yes, you're right that some scientists pointed out that there is a correlation between long-term solar activity and climate in the past. That is known. The correlation is known. So I think the existence of correlation between the solar activity and the Earth's climate is, I think, it's almost established, and most of the scientists agree in the existence of the correlation. There is a debate about the causal relationship between them, and also how much it can affect in the context of the current global warming is a very, very highly debated issue on which I cannot comment anything. Yes, but so that's one thing. But on the other hand, yes, I said that there's a huge super flare or a very short time scale phenomenon was not disaster in the past, only if it did not destroy the ozone hole significantly, and that may have happened in the past if I said the Carrington class is once in 100 years, and if 10 times larger than Carrington, which occurs in once in 1,000 years, occurs, it may significantly damage the ozone hole, according to the theoretical calculation. No one has found any historical evidence to indicate the depression of the ozone hole or ozone layer, but that may have happened. And that may be due to another global effect from the space weather. And also, as a possible past impact of the space weather.
Okay, sorry, we are missing one thing that I didn't address the global warming, and then about that issue, the global cooling and ice age related to the solar activity might be one of the issues that we have to think about, right? And then climate impact probably addressing the food chain, right? The food chain I didn't discuss here, but there is a person who is joining from FAO. Are you listening? Can you comment about the food security of the climate change and what might happen after the climate change happening in the past and the present? And can you address something about, we didn't put anything about the food, but food is a major issue about the climate, right?
I don't know much about the past, honestly speaking, this not being my area of specialization. But I can confirm, as the theme of this year's World Food Day says clearly, climate changes and food and agriculture must adapt to it. The thing we note the most is that the people who suffer the most from the impact of climate change on agriculture are those poor people living in developing countries. The thing, though, this alone is not enough. What makes it even more serious is that those are the very people who produce 80% of the food that all of us eat. And this is where it gets worse.
So this is not the direct impact of the consequences, but the secondary, but the biggest impact for us, right?
This is what I think.
The food production is reduced, and that might be attacking us more seriously than the direct impact sometimes, right?
It's enough to remember that those people are the producers of 80% of our food on Earth. I think this is important. And if I may add one data, one element, it's the fact that you already know, I've spoken at this university, 1/3 of the food that we eat, or we produce, is never eaten. I'm talking about food that is good to eat, but we let it rot or throw away for various reasons. Where does this food go? We throw it away, but where does it go? It goes to nurture the green gas emission. Okay. This information is not enough. Let me finish, because you asked me to speak. It's important to know that this food that we throw away becomes the 3rd cause of climate change, of green gas emission, after China and the USA. And so we need to do something about it. Thank you.
Thank you very much. Okay, we want to discuss more, but the time is already up. And if you have one question from the floor, I would like to invite, but if somebody want to comment something. So if not, we would like to conclude this session. Thank you very much for your patience.